Lesson 1 of Chapter 7 of Probability and Statistics. Our topic today is random. Our essential outcome is that you will be able to understand randomness and apply it when talking about the probability of an outcome. So, what I want you to do first is think for about 1 minute about what random means to you and how you see it in your life. So pause the video now, take some time to think. So in my class earlier, I asked students to pick a number between 1 and 10, and this is what I got. They randomly picked numbers between 1 and 10. If we notice, there are no one picked the number 10, and a lot of people picked the number 7. Why do you think a lot of people picked the number 7? Well, lucky number 7 is a typical phrase in our society, and so I think that kind of contributed to why people picked the number 7. So then it really wasn't that random because people had a choice in there. And so we're going to talk about some definitions for random. Random is, by one definition, having no specific pattern, purpose, or objective. It's of or relating to a type of circumstance or event that is described by a probability distribution. It's of or relating to an event in which all outcomes are equally likely, as in the testing of a blood sample for the presence of a substance. More definitions for random: proceeding, made, or occurring without definite aim. Of or characterizing a process of selection in which each item of a set has an equal probability of being chosen. Lacking uniformity of dimensions, laid without continuous courses, constructed or applied without regularity. It's unknown, unidentified, or out of place, odd and unpredictable in amusing ways. So we're actually going to use a definition for random. Our definition for random is going to be outcomes and choices are all equally likely to be chosen, and all outcomes have the same probability of happening. Human decisions, just so you know, are not random. We always have a reason behind it. It may be illogical, it may not be a smart reason, but we always have reasons, and so it's not random. So to be random, the outcomes or choices are all equally likely to be chosen, and all outcomes have the same probability of happening. And so examples of things that are random is in a deck of cards. Okay, there's 52 cards. We're not looking at them. We just pick a card that's random. We have no decision, no choice in that. Or rolling a 6-sided die. There are 6 sides. You roll a die. You have no control over what side lands up. Or spinning the spinner here. It just spins every time I click it and just randomly ends up in different sections. Okay, we have no control over that. So those are random. Also flipping a coin, that's a random thing. You have no control over that either. And so if we think about this, okay, what is the probability of rolling the given number in a die? The reason why I say 1 out of 6 is because there are 6 different outcomes. Each one of them is equally likely, so each one is 1/6. And if we add all these fractions up, we actually get 6/6, which equals 1.0, which is exactly what it should equal. So therefore, the rolling of a die is random. Okay, so this is an activity. I've changed it a little bit. You're supposed to roll with a partner, but we're going to ignore that. I ended up rolling a die many, many times, and this is what I got. You notice, okay, number 1, I got 40 times, 2, I got 22, 3, 29, 4, 34, 5, 31, and 6, 36. So yeah, some of these events happened a few more times. I got 1 a few more times. I didn't get 2 as much. But I did it randomly. I had no control over it. And if I continued to do this forever, the results would change. And each time I do this, the results are going to change because it's random. I have no control over it, right? So that's basically what random is. That's all I really have to say about it. But your summary and your questions, the essential outcome for today is that you'll be able to understand randomness and apply it when talking about the probability of an outcome. Remember, with random, every outcome has to be equally likely.